Good morning and welcome to the first video on hyperbolas to explain the notes that are listed on Schoology. In this video, I'm going to kind of give you an introduction to how hyperbolas work, and I want to compare them to ellipses so you have some frame of reference. So let's actually recall the ellipse, and let's remember some key features of the ellipse that will help us understand a hyperbola. So that's not a perfect ellipse, but you remember that in an ellipse, we had a center, right? So let's just pretend this is the center. And on either side of the center, on the major axis, which is the longer axis, we had two focus points. So let's just put them here and here. And these focus points were symmetrically located in relation to the center. So I'm just going to call this F1 and F2, and they are my focus points. And one of the key defining features of an ellipse was if we had a point, I'll just call that P, that the sum of the distances between a point on the ellipse and the two foci were constant. So what do I mean by that? Well, if I were to calculate distance 1, I'll just call that D1, right? Plus, I'll call this D2, distance 2. This addition of distances would be constant. Okay, and you may recall in a GeoGebra demonstration that, and you can go back and look at this, if I took P and I moved it all the way around the parabola, right? The D1 and D2 would individually change, but their sum would stay constant. So the defining feature of an ellipse was that the sum of the distances between a point on the ellipse and the two focal points was always constant. Okay, so in a hyperbola, it's kind of the same idea. So in a hyperbola, and I'm just going to draw the best that I can. So remember, a hyperbola sort of looks like two parabolas, right? We're going to learn that hyperbolas also have two focus points, and they're very similar to a parabola. They're going to be in the general same location. So let's say this is F1 and this is F2, okay? And let's say I have a random point on the hyperbola. So I'm just going to call this here point P. All right, and just for illustration, I'm going to draw this distance here, I'm going to call D1. And this distance here, I'm going to call D2. Okay, well, in a hyperbola, what's going to happen is the differences will be constant. So what's going to happen is the D2 minus the D1 is going to be constant. Okay. Now, you can imagine, right, taking point P and moving it, right, all along this part of the hyperbola. The individual units of D1 and D2 will change, but the differences between them will remain constant. So just to summarize, a hyperbola is the set of all points P such that the difference of the distances from P to two fixed points called the foci is constant. Okay, and similar to parabolas, we're going to learn that not only are we going to have vertical hyperbolas, but as you can imagine, we will also have horizontal hyperbolas. So I'll just draw a quick one here to give you the idea. And the same features would apply, right? My focus points would be here, and it would be the same idea. If I had a point P, right? This is D1, this is D2. The same idea would happen in a horizontal hyperbola. So in the next video, we're going to go through the math of a horizontal hyperbola and the math of a vertical hyperbola. As always, please email me if you have any questions.